So, what did you learn about problem solving? What did you learn about teaching problem solving? And what would you do differently? So, if you haven't answered any of those questions, I'll just bring the mic over and you can say what you think.
Problem solving, I think, is a strategy that is really good in groups, working with other people. I think it's great to have other alternative viewpoints, and I think that that is really powerful when you get kids to talk about things and to take chances and to feel it's okay to make mistakes, but to learn from those things because they sometimes lead to better answers. And they actually learn so much more through that conversation, through that, you know, experimental things like you had us go ride the bike. I mean, you could have just put a picture up there of the tracks and that, but doing that really made you really get more involved with it, more excited about it. So for me, that's, yeah. And I don't think I'd do anything differently. I think you're awesome. So, yeah, I thought this was great. Yeah, I don't know.
Somebody else? Okay.
Just coming here because at any of these math teachers, you get to be a student, and you get to feel what it's like to be a student, and you get to enjoy being stuck, and you realize, hey, I don't want to know the answer yet. I like trying to figure this out, and so if once a month I come and struggle and be stuck with something and wonder and be curious, that helps me know that's what they need too. So it's good to be the student every once in a while.
We had this discussion earlier. By coming to the circle and seeing a struggle and how we can take something that we're really totally unsure about, combine some ideas, bring it all together, shows us what we really need to do for our students and let them free. You know, not just stand up and say, this is what you do, this is what you do. Because we went from 3, 4, 5, 6 different areas to get to one thing. And some of us will still leave here thinking about it tonight. And that's the beauty in learning, and that's what makes it so cool. And I wouldn't change anything either.
If you want to think about that last question in a different way, you know, how might you adapt this to your own classroom teaching middle school students?
I have nothing sensible to add to middle school teaching because I don't teach middle school. I teach in university, and all I can say here is what we have is a classic research problem in mathematics. Because even if we have good undergraduate students, we say prove that theorem, and we give them all the list of conditions and all the things that they should do, and they go and do the calculation. But actually, solving an open problem or an open research thing like this, you don't know what the important information is. There's a lot of things that you don't know what's relevant and what's irrelevant. And very often the final thing, which is actually coming up with a solution, is the easy part. It's sifting all the relevant and irrelevant information one from the other and finding out what the optimal set of hypotheses and the essence of the thing is. And that's the thing to focus on, I think. That's often as important as the technical mathematical argument and the calculation that finishes everything off. Sifting the evidence. That's what Sherlock Holmes would do, I guess.
One more? Heather?
Well, I was thinking about teaching this with middle schoolers because I do this kind of thing every Friday with my kids, and one of the biggest problems that I'm coming across, and it's not a way of doing things differently, but more a question that I have, is time limits. There's such a short amount of time in the class day and the amount of time that we're given with the kids, and it's so hard to leave something and then come back to it over periods of time when there's certain things you're supposed to cover, and so I don't have an answer to that, but it is something I'm thinking about. How do I take some great experience like this and with students who don't know about tangents or any of those sorts of things? How do they come to a satisfying conclusion in a reasonable amount of time that I can justify as a teacher of a set list of standards?
I just know from teaching also middle school and high school for many years in the past, what I would do is if I didn't have the time, I would try to look at other subjects I'm teaching and try and incorporate them into the mathematics. So make something relevant to both subject areas so it stretches out your time a little bit better. And then not just do it all in one period, but touch upon it and then come back to it. And like a project-based situation where you're exposing them to a certain problem, but you don't have to go into all that detail at first, and you come back to it and add a little more detail and do a little experimentation outside at one other time, and then another time come back and look at your tracks and sort of build up to it and use your time that way, because all those little elements add up to a much richer experience than I know it's hard. I know it's hard for teachers, but I'll tell you it's well worth the time doing that. It really is. Not just for you, but for the students especially.
Well, thanks so much, everyone. Thank you, James. Thanks, James.